Good morning, class. This is Mr. Eggleston, and this is the lecture for lesson 5.3, Exponential Growth and Decay Word Problems. Basically, this is the application of exponential functions. The most straightforward application is exponential growth and decay. There are two types we're going to look at. We're going to just have your straight up exponential growth or an exponential decay problem. And then on the second video, this is the first video, on the second video, it will be about money. That's so we have two learning targets here. Here's the learning targets for 5.3 applications of exponential functions. We're going to learn on the first, this is what we're doing today, or in this discussion, right here. That is, write and apply exponential growth and decay functions using a percent rate of change. So that's the first learning target, and so you would want to, trust me on this, you want to write this down right here. Okay, well actually it's written down for you except for maybe the purple. Okay, writing exponential functions with a percent rate of change. Here's the function form. It's pretty straightforward. It's going to be a f of x equals a times this weird 1 plus r to the x power. All right. A is the initial value. That's how much you, like if it's money, that's how much you initially invested. If it's the value of some artwork that's appreciating, that's gaining value, it'll be the initial price of the artwork, whatnot. And then R is the percent growth or decay, depending upon if the function's growing or getting smaller, as a decimal, written as a decimal. Now the thing is, R is positive if it's growth. And that's because if R is positive, 1 plus R is bigger than 1. That's exponential growth. Again, R must be a decimal. If R is negative, if decay. All right, so because 1 plus a negative number is less than 1. And then this is the second learning target. It's a neat application that we'll talk about after the quiz. All right, so we're just focused on the learning target number 1 in this. That's what all these word problems are. So on the first one, it says the word problem. Let's see if this is still saved. No. Okay. Remember, this is all based on the fact that P, or let's see, what letters did I use? I think they said f of x. So it would be f of x equals a times 1 plus r to the x. So find the growth factor for the world population. Well, it says the world population in 2000 was approximately 608 billion. The annual rate of increase was about 1.26%. This is R. And we have to write it as a decimal. Do not write 1.26 for R. It's 0.0126. Okay, so it says find the growth factor. The growth factor is 1 plus R, which is 1 plus 0.0126, which equals 1.0126. Now notice, the growth factor is bigger than 1. Thus, this is going to grow because this is the base of the exponential function. Now, again, it's P of x equals A, which is the initial amount, and in this case, A equals 6.08 billion. Now you could write all the zeros down and write it out as a billion, but we're just going to know that 6.08 is a billion. So our numbers we're going to get out of this is going to be in terms of billions. So this is going to be 6.08 times the growth factor of 1.0126 to the x power, where x is years equals years since 2000. Okay? So let x be the number of years past the year 2000. Find the world population in 2010. So basically in the year 2010, x equals 10. And so they want you to calculate P of 10, which would be 6.08 times 1.0126 to the 10th power. Now I'm going to show you how to use your calculator on this. Okay? Again, that's kind of hard to read, the exponent. The exponent is 10. Okay? So how do you calculate this? Obviously, you need a calculator. So you have a calculator for the quiz. Okay? So I'm going to clear this out, and I'm going to type in 6.08 times our growth factor of 1.0126 raised to the 10th power. You hit equals, and you get this ugly decimal. All right? But all we're going to go, since they gave us an initial population to 2 decimals, or 6.08 billion. We're just going to take this to 2 decimals. So it comes out to be equal to 6.89 billion people. Okay. So there you go. And again, maybe I should make that red, the growth factor, because it's the same thing as above. Okay. Now, that was appreciating. That was something growing. Now this one, notice the word choice. It says it depreciates. Depreciation means it gets smaller. Okay. So this is decreasing. So if R at the rate of 14.3%, so that's going to be 0.143 as a decimal. Write a function that models the value of the computer. So this is going to be the value of the computer P of, I'm just going to call it T, equals the initial value, 6,500, times 1 minus 0.143. Notice it's minus because we want our base to be less than 1. Okay, which equals 6,500. And now I just got to figure out what 1 minus 0.143 is. Go back to my trusty calculator. Again, you can't really do this. You can't do this without a calculator. All right? So it's 1 minus 0.143. That works out to be 0.857. So this is times 0.857 to the t power, where t is years after what was this? Okay, t equals 0 is, or actually I could just say it's years after purchase. T equals years after purchase. Okay. So it says find the value of the computer after 3 years. So that they want you to tell them what P of 3 is. So P of 3 is going to equal 6,500 times 0.857 to the third power. Okay, so now this is just a calculator problem. You're just going to type it into the calculator. That's why you need one. So I'll clear that out. Oh, nope, I'll hit equal. And then, it's just not going to let me do it. All right, so it's 6,500 times 0.857 to the power of, they said after how many years? After 3 years, to the power of 3. Notice the value of this computer went from 6,500 to 4,000 basically. So in 3 years, it depreciated, it lost close to $2,500 worth, $2,500 worth of its value. So this is $3,991.81. That is the value after 3 years. Okay. Now you notice the rest of these are pretty much the same. Population of a certain animal species decreases at a rate of 3.5% per year. You have to remember 3.5% in decimals is 3.5% equals 0.035 as a decimal. So write the function that models this. Well, it's decreasing, right? This is the last one. I'm going to have you guys actually do the calculation. I'm just going to write the formula. Okay. Actually, no, I want to talk about B because we're not going to graph it by hand. So we're going to use guess and check once we get the model. So we have P as a function of T. Its initial amount was 80, right? It says 80 somewhere. Yeah, 80 of the animals in the habitat. So it's going to equal 80 times 1 minus 0.035 to the T power. Okay, which equals 80. And then what is 1 minus 0.035? Is 0.965. So it's 0.965 to the T power, where T is years after purchase. All right, then it says graph. And doing something like this, to graph something like this by hand is a pain in the butt. So I would recommend using a graphing calculator to solve by graphing. All right, so I'm just going to go ahead and use a graphing calculator. I was using a scientific and guessing and checking, but I'm going to go ahead and use Desmos. So here's Desmos. Here's a bunch of problems I was doing previously. So again, sorry. There we go. So they want us to type in, oh, sorry, 80 times 0.9. Golly, why is this not moving? There it goes. So it's 80 times 0.965 to the power of, and now I'm just going to type in x. Okay. And that is the function. Now I'm going to go ahead and make this go from 0 to 20. 20 years. Oh, come on. And then my y-axis is going from 0 to 0 to 80. And it's like this. Okay. They want to know, oh, that's 8, and that's supposed to be 80. Sorry. 80. There it is. Okay, let's find y equals 80. Okay, so we want to know when is the population less than, I shouldn't say y equals 80, less than the value that they're talking about. What value was it? They said below 15 animals. I'm looking right here, below 15. So we're going to set the y equals, we're going to graph y equals 15, and we see we have this. And we can see that they intersect right there. So it'll take about 46.99 years, or 47 years, before t has to be greater than 47 years before the population will drop below 15. So about 47 years. Okay. And we just look to see when the graph reaches 15, and Desmos is such a great tool. It tells you right off the bat. Trying to graph that by hand would be a pain in the butt. And basically what we did was this. We just set this equal to 15. And we want to know at what time. Okay, we did it graphically. We solved this graphically. We're going to learn how to do this algebraically after the quiz. All right. Okay. Number 4. I'm going to let you do the rest of these. 4 and 5 and 6 and 7, 8, 9. This is your work for this group. This lesson. All right. I hope this made sense. If you have questions, please ask. Vaya con Dios.